Hello and welcome to our YouTube tutorial on classification in machine learning. Today we will be talking about classification algorithms and building a simple classification model step by step. But before we begin, let's quickly understand what is classification and why it is essential in machine learning. Classification is a type of supervised learning where the goal is to categorize data into predefined classes or labels. It is widely used in various applications from spam email to non-spam and detection to medical diagnosis and sentiment analysis on social media. Next, we will be trying to understand classification. Imagine you have a dataset containing information about fruits and you want to classify them as either apple or orange based on features like color, size, and shape. This is where classification algorithms come to play. So there are several types of classification algorithms, each with its unique characteristics and suitability for different types of datasets. Some popular ones are logistic regression, naive Bayes, and decision trees, support vector machines, random forest, and k-nearest neighbors. Next, we will create a sample classification model and we will do the pre-processing model, data preparation, and all these things on our Jupyter notebook. So today we will be building a classification model for stroke prediction. But first of all, we will try to understand what is a stroke. So stroke is a medical emergency. A stroke occurs when blood flow to a part of your brain is interrupted or reduced, preventing brain tissue from getting oxygen and nutrients. Brain cells begin to die within minutes. Through this data, we will try to know more about strokes and make a model to try to stroke prediction. So there are some risk factors for having a stroke. For example, age. People aged above 55 years and above. Hypertension. If the systolic pressure is 140 millimeter or more, or the diastolic pressure is 90 millimeter or more. And the next one is if the cholesterol level in the blood is 200 milligrams per deciliter. And there is another feature that is called smoking, and then comes diabetes and obesity. If the body mass index BMI is 30 or more. So let's start building our model. I have already written down the code and uh, so the first one is importing some libraries that is related to for the visualization part. I have imported matplotlib, and for the data pre-processing and data importing I have imported numpy and pandas, and then there is seaborn and plotly. And for the data preparation and data splitting the data, I have imported and test split from scikit-learn, and the pre-processing standard scaler for doing the pre-processing, scaling our features which are not in the same unit. And then I have also selected cross validation score, and there are some models that we are going to try in this code, like a logistic regression, support vector classifier, and random forest classifier. And then there are some accuracy metrics that I have imported here, that is like confusion matrix or classification report. So let's start. Here I have saved my data, stock data, and this is our data. So here we have, as we can see, that we have some columns related to heart stroke, that is gender, age, hypertension level, and heart disease. Has is the person married or unmarried, and their work type, if he is working in private sector, self-employed, or like a government job, and then where he lives, is he living in like urban or rural area, and then their average glucose level, and then body mass index, and smoking status, and then comes our target variable, that is stroke. So uh, by printing df.info, we can see that there are id has like a 5110 rows, and same for the gender and same for the other values. But as we can see here, that BMI has less values, that is like a 4909. So we can see that there's some data missing in the BMI part. And then we will try to print the describe function, And here we can see the statistical description of every parameter. For example, our age has 5110 count, and then mean lies around 43 years, and then comes hypertension, and then heart disease and average glucose level, BMI. Now let's find out the variance feature distribution. As we can see, we have very good distribution for age, and then we have some outliers for BMI part, and average glucose level is reasonable because the normal average of blood in sugar is less than 140, and that may not be good. This feature will not be helpful, but to know if diabetes have correlation between diabetes and strokes. So now comes the data summary for checking the missing values. As I have printed here, we can see that there are 5110 rows and 12 columns, and then name of features, all the features that are available in our data set. And then we can see that here, there we have 201 missing values, and a unique values in each column are given. There are three types of gender, maybe male, female, and trans. And next one comes is age. We have 104 values for age, different values for age. And then hypertension has only two values, and heart disease has only two values. And we can see that BMI has 418 distinct values, and smoking status is 4. So we can say that there must be some people who have left smoking, or that kind of thing. So now we will try to visualize the data set based on the stroke. So let's try to print it here. And as we can see that only 5% of the people have stroke. And now let's break down the data set based on the gender. So as we can see here, more than, around 3,000 people are female, and like uh, less than 2,500 people are male. And we can't see anything significant for other kind of gender. Correlation of each continuous value with glucose level. So here we have visualized some features which may be have correlation with average glucose level. And as we can see that average glucose level is high with old people. As we can see that here average glucose level is higher for the people who are older. And for BMI greater than 40 have low glucose. So here we have plotted a heat map correlation to find out the correlation between uh, two variables. And as we can see here that no correlation is near about around 1. So we can safely say that there is no correlation between a stroke and BMI, or any kind of a stroke and BMI, and average glucose level and BMI, stroke, and all these kind of variables. So now we will print the BMI to find out if there are any kind of outliers available in the data. So we have plotted a box plot. As we can see here that we have many outliers, but before we fix this, we must study BMI first. So BMI is body mass index. It is a value derived from the mass and height of a person. So here we have dropped we have found out the a number of people who have a outlier BMI. So here as we can see here that people who have greater than 50 BMI is 79. And then find out how many people of those outlier have stroke or not. People if we try to drop those people who have outlier BMI, then we will drop the we will also drop the null values for the BMI, and then print the values. Then as we can see here that like no missing values are available now, and then like we will try to create a new data frame for the categorical data only, and then like we will encode it and then append it with the original data. Here like we can see that like people who have a stroke, and here we are trying to find out the correlation between marital status and stroke. So here as we can see here is that like people who are married, so there is higher chance of getting a stroke if you are married. And then like from here we are trying to like find out the correlation between the work type and the stroke. So as we can see here that like the chances of getting a stroke are higher when you are working in private, and the lowest chances of getting getting a stroke is when in case of a child. Now we are trying to plot a graph between smoking status and stroke. So as we can see here that so being a smoker or a formerly smoker increases your risk having a stroke. And now we will do the same with the residence type. And as you can see here, like residence type has nothing to do with the stroke. We cannot take it as a standard. And now we will correlate it with the heart disease. If a person is having a heart disease, is it like very common for the person to have a stroke as well? So as we can see that like people who had a stroke do not have any heart disease, but that does not prevent it being an influencer. Most people who have had a stroke do not have any heart disease, but that does not prevent it being an influential factor. Now let's find the relation between hypertension and stroke. So if you are having more than 25% of the stroke cases, they had hypertension. So from the above data analysis, we have some points that we can write down. Is that like average glucose level is high with old people, and BMI greater than 40 have low average glucose, and being unmarried reduces your risk of a stroke. And then comes being a smoker or a formerly smoker increases your risk of having a stroke. And more than 25% of stroke cases they had hypertension. So now let's do the data pre-processing part. So first of all, we will have to encode the categorical features like residence type, ever married, or gender. So what we are doing here is we are applying categorical data which has only two categories. We will just encode it manually. Like if X is equal to urban, then one, otherwise zero, and same with the ever married. And if person was married, then we will encode it as one, otherwise zero, and same go with the male. And um, for the continuous values, we will scale the features. So here we have imported a standard scalar class, and then created a object of that, and then we will be feeding average glucose level, BMI, and age, and then merge the categorical data and the continuous data. And then as we can see here that this is our final data set. Now we know that ID is not a useful feature for predicting the stroke, so we will drop the ID column, and then we will check again for the null values. Now let's create a target and features. So we will for the features we will drop the target column and then save it in the X, and we will do same for the target variable. We will select the target variable and save it in Y. And now we are doing the splitting part, splitting the X and Y for X trend, X test, Y trend, and Y test. And we are taking 30% of the whole data for the testing part, and 70% for the training part. So here we have imported a support vector classifier, and we have fitted the we have fitted the model with the data, and then we have calculated the score for the training score and the testing score, and then we have predicted the outputs, and then we printed the confusion matrix and accuracy for the same. So yes, here we can see that like a training score is 94.71%, but testing score is better, that is 96.08%. And as we can see here, like there is no misclassification between the um, data. As we can see here that like this is true positive and this is true negative. So we have 1473 true positives and 60 true negatives. And now here we have applied a random forest classifier for the same data and fitted the data into the model and then calculated the score and the um, have done the prediction part and then calculated same. And here we can see, as we can see here, is that like we have 99.97% accuracy in the training, but in testing we have only 95.95% accuracy. And as we can see here that our random forest algorithm has misclassified two examples. So this is this is false positive. That means there are two um, examples that have been misclassified. And now here we have imported a logistic regression. Now we are doing the prediction, same prediction part with the logistic regression. Here we have imported a object of logistic regression and then calculated the testing score and then printing the testing score. And then I also have predicted the output for X test and then printed the accuracy matrix and classification report. Here we can see that testing score is 94.97%. And here we also have printed precision, recall, and F1 score and support as well. We will be discussing all these variables in detail in some other video, but here we are talking about the accuracy. So as we can see here is that 1455 examples have been predicted properly, and 77 true negatives have been found, and there is only one example that has been misclassified. So now we will calculate the feature importance using logistic regression. So coefficient is the part which is multiplied by the features. So by doing the model dot coefficient underscore 0, then we can print the the coefficients of the all the features. And then we I have printed like a list of columns and then sorted them with the based on the coefficient. So here we can see that age is the best thing that is giving hint about the stroke. And then comes hypertension and then heart disease and ever married. And so all these columns have been printed in order of their relevancy for the stroke prediction. So this is it for the stroke prediction classification. And I will also be creating new notebooks and to find out, stay updated, and do not forget to subscribe my channel and comment if you have liked the video.